This is Unit 4, Module 1, Lesson 2, Parameters. There is a fast start activity for today, so please log in and do the fast start activity first. Also, there is startup code. Download the startup code. So today we're going to talk about parameters. And we've actually dealt with this a little bit. We've never actually used any formal names for this. But when we send information to a method, that information gets sent as an argument into a parameter. Let me say that again. It gets sent as an argument into a parameter. So compared to zebra is the argument. Much like if you did the square root of 10, 10 would be the argument of the square root. You guys may have recognized that word from math, the word argument. You just never had to deal with the other side of it. The other side of an argument is a parameter in computer science. So length has no argument sent. Equals has howdy as an argument, and character at has one as an argument. A parameter is the local variable in a method header that holds the data that's sent in. Let me say it again. A parameter is the local variable in a method header that holds the data sent in. The data type of the parameter makes a difference. Think primitive versus class type. In other words, if I set the parameter to be a double, I can't send a string. My argument can't be a string if the parameter is a double. It doesn't make any sense. So the argument has to match the method parameter definition. So when you think about parameters, parameters are how you set up a problem, right? What are the parameters of the problem? It's at the beginning. It's something you set up in the beginning. The argument happens later. So if you want to think about this as a court case, this is probably a pretty good analogy. Your parameters are your opening statements and your initial charges and everything that happens, the preliminaries that happens before the court case. But then once the court case is on and going, you make an argument. So the argument occurs after the method has been designed. So the argument is what the user or the programmer sends to the method parameter. Just trying to give you ways to remember it. So let's take a look at an example here. This is a method. We talked about declaring them yesterday. It is static, which means you don't need to construct an object for it. It lives within the main class more than likely, or within a class. And you would call it just using the word sum. Int A and int B are the parameters. So if somewhere in my program I did my public static void main, string int, somewhere in there I did sum 1 plus 2, whoops, my fault, not plus, sum 1 comma 2. The 1 and the 2 are the arguments. The 1 and the 2 are the arguments. The A and the B are the parameters. So what I would like you to do is to write a method. Open up Dr. Java, start a new class, call it what you will. If you need to open up some other file, you can, but I did give you a template startup file to start with, so you could use that. I would like you to create a method. I would like you to name it, square it, make sure it takes a double parameter, and prints its square. It prints it on the screen. So much like we did in this method, instead of adding, you're going to print the square. So it's very similar to this method. And you're going to call it square it. So I'll leave this code up on the screen so that way you have something to look at while you're writing the code. So I'm going to pause the video and you guys are going to work on that for a couple minutes. Okay, I'm about to show the answer. So let's look at the solution. Here's my answer. Let me try this. So public static void square it is the name of the method, and then I double, and my variable is n. That's better. I just do a straightforward system.println n times n. It's just printing out the answer, nothing fancy. This all was given to you. All you had to do was call the method, square it, and send some information. So let's talk vocabulary. Value is the argument. Value is the argument. N, double N specifically, is the parameter. So we have our value and argument pair. Value is the argument, double N is the parameter. The method is public static void. It's public because everyone has access to it. It's static because we don't want to have to create a class to use it. It exists inside of our class that we've been designing. It's void because it doesn't return anything. We'll talk more about how to return things in the next lesson. And we called it square it. You can call it anything you want, but that's what we call it. This is our parameter. This is our action that we're going to do. Here's our public static void main with its, what do we call this? This be its parameter. Public static void main has its own parameter, string. We have our scanner set up that was given to you, our printout, our double, get the next double. And of course, this is our call to the method. Now remember, we could call this a different way. We could use the name of the class. Dot square it. Don't need to. Java knows that because we're calling this within the class, since I'm not listing the name, then it must be the thing it's inside of. It defaults to that. If we were using the math class, we have to identify math dot. To say we're using the math class. We can't just call ABS. We have to use math.abs. Now, depending upon how we import it, sometimes we can just use ABS. It's all in terms of what Java recognizes as local to itself. We could also use this operator here and say this dot square it. We'll talk more about that later. But for right now, the simplest way of doing this is calling the method with the name of the method because it lives inside of the same class as the main method. So because these two things live together in the same class, we can just use the name of the method. So how does this relationship actually work? Is the number that's stored in value copied to n? Or is it the same thing? In other words, if I were to change n, would it change value? That's really interesting. Well, you could experiment. Inside this code, just for fun, we could change it. It'll change what it does, but that's okay. Just do n++ semicolon right after you print the answer. Because now we know the value of n will be 1 more bigger. Right after you print the answer, do n plus plus. And then, after you call square it, value, print out value. If they're the exact same thing, value should have gone up by 1. If they're not the exact same thing, value should have been the original number that was typed in. So pause the video, go ahead and give that a try, and we'll see what the results are. So you should have noticed after you did this, if you didn't, pause the video and do it. After you did this, you should have noticed the value didn't change. In fact, what happens here, because it's a primitive, it's making a copy of the value. If we change n, it will not change value. It's making a copy because it's a primitive. The argument value is separate from the parameter n because it's a primitive. Now, I'm emphasizing the fact that it's a primitive for a reason. If it was an object, we might have a different story, and we'll talk more about that later. That's a more abstract question. When we start getting in more detailed questions about scope, yes, that word's going to come back up again. The scope of n is local to this method. So if I have another variable n down here in public static void main, they're not associated. Because if we look at the curly brackets here and here would contain all this information. The curly brackets up here contain all this information. So if I have a variable n, and you could try creating this, create an int n and start putting some numbers into that, and you'll see that it has no effect whatsoever on this n. They're separate. The curly cues put them in separate blocks, separate scope. And this is where I said this is going to start getting thick. We need to start keeping track of who has access to what. Where does the variable really live? N lives in this method and only this method. Every time I call square it, it's creating a different n. Once I'm done this method, n is gone. It doesn't matter anymore. The method's over, it's gone. When I'm talking about primitives, we have a deeper conversation when we talk about objects. This becomes a lot harder. So, let's look at the rules for parameters. Parameters, you can have as many as you need. There's no limit on the number of parameters when you're designing a method. You can have any combinations of types, objects included, which we need to talk about, how that works. But we can use objects, we can use any primitives, doubles, as many as we want, any combination we want. The values are from main or the calling method. In other words, whatever method calls it, that's where all the numbers come from, or all the objects, whatever it is, come from that go into the method we're designing, that go into the parameters. So the values being sent are called the arguments. So the arguments come from the method being called, or the main method, depending on what's calling it, and are sent into the parameters. Arguments go into the parameters. Parameters are the setup. You have to design it with the parameters. When you use it, you send the arguments. So finally, let's get to the definition of an argument. You probably gleaned this already, but an argument is the data sent to a method. The argument data type has to match the parameters. And order matters. If you have parameters set up such that it's expecting an int and then a double, if you don't send arguments that are an int followed by a double, you're going to get an error. So order is important inside of your method calls. So the arguments have to be in the proper order that the parameter is expecting. If it's not, you're going to get an error. It's going to say type mismatch because clearly it's getting the wrong thing. So, parameter versus argument, this is the parameter. And I'm really driving this home. This is the parameter. This is the argument. Do that again. Parameter. Argument. It's like computer science Sesame Street. Parameter. Shh. Argument. No, don't get the joke. Okay. So, there's a practice assignment in there. You have to first download the practice Java code. And you're going to write the following methods. See if this works. No, it didn't work. All right. So you're going to write month name, and it has a parameter of an int, and it's going to output the month name for a number entered. So if you send an argument of 8, it should print out the word August. Month days, and again it takes an int, it outputs the correct number of days for the month. For example, if you type in 4, you should get 30. If you type in 10, you should get 31. So we're writing methods. Date gets a D, it's another int, and it outputs a word for the day. So for example, 11 prints out the word 11. Wow, this really would have been useful in another thing that we did at some point, wouldn't it have been? There would have been a horoscope program that this could have been really useful for had this been done. This is essentially what we're doing here is we're refactoring the horoscope program. We're taking the horoscope program and building methods that would have been useful inside that horoscope program. How could you change your main method so that the user can enter something like, please enter the month number of your birthday and your birth date. You entered 56,893. We want to make sure the user can't do that. We don't want them to enter that the month day is 56. We don't want to let them do that. So we want to stop them. So we want to do the error checking inside the main method. What happens for people whose birthday is February 29th on leap day? How do you handle that? What other methods and or information might you use to fix this? So this is a question that you have to type the answer to. This is not code. In general, why are birthdays bad passwords? Just thinking about it. Write a function that swaps two integer values passed in through parameters and prints them backwards. So two integer values and prints them backwards. Write a method called real-time that accepts a number of seconds and prints the correct number of hours, minutes, and seconds. So this is your practice assignment for you guys to work on tonight. Not necessarily expected to be finished tonight. Expect another class period to work on this and get this done. Okay? And that's it for our lesson. Just a quick note, function and method, those two words often mean the same thing inside of Java. Other languages, they are different, but inside of Java, they mean the same thing.